So firstly we will create the list. For that we should have two arrays. We are actually creating or implementing linked list using arrays. So we will create two arrays, one for storing the actual data, which we have named here info, okay, but you can name it whatever you like. So we will create one array which will be storing the data item of the linked list, and we will be having a linked array which will be storing the next pointer, the pointer to the next node into the same data item or the node of the location. Let's say this is the node. So for this we have created info and this is the link. So we created two arrays parallelly. As you can see from here diagram, this is info storing the actual data and this is the link address of or pointer of the next node. So secondly, we also require one or two variables, one for star which is for storing the head or header node, which will be having the first address of first node of the linked list, and the null variable, because this with null variable it will be clear that it is the end of the list, or we can say this can also define us to check if start or head is null, which will define that list is empty. So this will be beneficial for checking overflow and underflow conditions of the data structure. So third thing is we have two arrays, one for info and another for link. We have two variables, start for storing the head address and null for checking the overflow and underflow condition, also to define or refer to the end of the list. And we also require one more list, which is avail. Avail list will be having its own link to represent, because this is going to be again another linked list, but this will be storing the available space out of the list. Let's say we have created linked list and we have different nodes onto it. We have deleted some of the nodes out of it. It means those space will be vacant. That space will be available. So that's why we created the avail linked list separately to store the available space onto the linked list. So this list will be used when we need to insert the items into the linked list, because from where this is the empty space, so we can pick the node or the space out of the available linked list, avail linked list, and we can insert the item, and then we can change or update the pointers so that that node will be inserted inside the linked list. So these are the things that we require for creating the list, and that list the list that will be created will be in the form of this. So this, let's say this is a list that we have just created. We have one array for storing the actual data. We have another array which will be storing the address or the next pointers to the which will be pointing to the next nodes. Then we have a start which is going to store the address of first node in the linked list, and we have a avail list which has its own link array which will be storing the next address. So this is the actual list that has been created by this. Let's see, now we have here the example. Let me repeat this example. So in start we have the value 9, which means 9 is the address which has the first node in this linked list. So how we define info, because this is array. So inside the square brackets we write the index or the memory address. So 9 has the first node of linked list. So we searched for the 9. So this is the first data element of the linked list. And alongside this, parallelly we have a linked array which stores the address to the next point. So this is the 3 value, which means at the memory location 3 we have a next data value in the linked list. So we will go to the third location. So this is the third location. So this is the second node, second data item, which will be represented like this. This was the first node and this was the second node. Along with this, link of the info is, link of the 9 is 3. This is what is written here. Firstly, start has an address of first node. So we picked up that one and then we checked out the item at there. First, the start variable, it only stores the address. So it doesn't have any link to this. But when we reach to the memory address 9, we picked up the data item, and parallelly we have a pointer which points to the next memory location and which has the second node, and along that we have another memory address, and we will go to that 6th location. It is empty here, but it has next pointer which is at 11. So we move to the 11th location. We came here, we have a third node here, and we picked up the next pointer 7. So we go to the 7th location. Where is 7th location? It is x value, and it has 10 pointer. And now we will go again and go to the 10th position. Now we came to the 10th position. This is the next node. The pointer is 4. We go to the 4th location. This is the last node or the last data item onto the list, and here comes the null or the end of the list. So list got ended here because here it is the null value. So this is how it is called written. So this is how you create the linked list. In previous slide I told you can implement this by using structure in C and by using class in C++. We will look at the coding part where we will implement the stack using linked list. So you can use the data item here and the pointer again. I'm writing. So next pointer. So this is how you implement the linked list, how you create the linked list inside the memory. So this was the logical way and this was the programming way. So you need these things and you have to remember these things, because this is going to help us when we will be applying insertion, deletion, and also when we will implement stack and queues using linked list.
If you found some value in the content shared in the video, please hit the like button below. Also do subscribe to the channel and don't forget to click the bell icon so that you don't miss any updates. Thank you for watching.